Testing, testing. Hey, there you go. Now we're talking. Um, Literally, now we're talking. Now I'm talking. Okay, where are we? Let me close. I have a bunch of windows open. Work stuff. Do I want to? I don't want this. I don't want this either. Uh, what do I have here? I don't want this either. And I want this. Okay, I think we're good. Beautiful. Three, two, one. Hello! Welcome everyone. How is everyone doing right now? Good morning, good afternoon, good evening, whatever this may find you in time, in place, in the world, physically and emotionally, I guess. So, I'm going to take this off. I'm going to take my jacket off from here so that videos look consistent across time and space too. That's also the reason why I always wear a black t-shirt, so that all the videos look the same. I can't really do that with my haircut, but hopefully there is yeah. Anyway, I'm digressing here. So, first of all, welcome everyone. If this is your first time here, my name is Jose Luis, and I run this thing called Parametric Camp. We do computational design live streams. We sit down, we write code together. We in the company of beautiful people like Joe and Michael, which are already part of the community, and I've seen a lot here in the chat, in the live streams. Thanks for joining us, for joining me. I'm very happy to do this in the company of human beings. And we record tutorials, we edit them, we publish them, and then it becomes material that you can use to learn and to improve your computational design skills, hopefully. Now, what are we doing right now? So we are wrapping up a series, and a few other things. If you want to know when we go live, you can follow us on social media. You can subscribe to our Google Calendar, and then events will pop up telling you when we're going live. And on top of that, if you want to join our conversation throughout the week, you can join our Discord server. There's a link in the description of this video as well. And introduce yourself, say hi. Where are you coming from? Why are you interested in these things? I'm always very excited to meet new people and to know what drives individuals to learn about computational design, I guess. Yeah. And so what are we doing today? Today we are continuing with, let me pull up my notes actually. Where are my notes? These are not my notes. These are the other notes. Today we are continuing and hopefully getting closer to wrapping up the playlist that we've been working on for the past few months, Advanced Development in Grasshopper. If you're new, what we've done is we have learned how to write computer code. That we did that actually in a playlist like last year. So we have a full playlist learning C# from scratch. But in this one, assuming you know C#, what I wanted to explain is advanced techniques on how to develop and write your code inside of Grasshopper, the parametric modeling environment for rhinos. And we did this by talking about Rhino Common, talking about how to create geometry with code, etc., etc. And then I explained prototyping using C# script components. And now we have moved on to actually natively developing native components for Grasshopper, which is being a lot of fun actually. So what are we doing today? Today we are continuing with the playlist. Let me share my screen. So we were here. Where were we? We were here, and these are some other notes. All right, so we need to talk about data structures in Grasshopper. So we need to talk data trees. Okay, we need to talk data trees. Oh, what is that? That's like a ghost. Sorry, I have a ghost patch of color. Yeah, it's gone. So, Andres, good morning. So we have to do data structures. We have to do data trees, which are different. in Grasshopper, and we have two examples from the plugin, and do a few examples. We're going to do a few examples. So that's going to be one video. We're going to do error handling, and that's going to be super similar from what we did in C#. Auto updates, that one is a little more complicated. Yeah, that one's going to be a little more complicated. Okay, we'll deal with that whenever we get there. So, and version, version management, external libraries. Okay, so this is going to be, this was number 10. So this is going to be number 6. This is going to be probably number 7. This is going to be number 8, auto updates. And then 11, simulation. Updates in simulation. Okay, I'm not sure that we're going to get to this today. That would be nice to get to this. This would be nice to get to as well. Okay, so let's start with data structures. So for data structures, what I would like to do, hey, no, welcome. Yeah, 100 is next week. Oh, by the way, that reminded me. So next week is the 100th live stream of Parametric M. I can't believe we've been doing this for 100 times already. Anyway, so I have a special surprise for next week. It's going to be a little bit of a special live stream. We're going to have guests actually. So, and it's going to be really cool. So if you are, if any live stream you shouldn't miss, perhaps that's going to be that's going to be next week. Okay. So yeah, make sure to join us. It's going to be a lot of fun. Okay. All right, going back to that, to here. So where are we here? Data structure. So lists is in native. So we saw. Okay, so I guess here. Okay, so data structures in Grasshopper. So what do I want to talk about here? We've done already outputting lists, but we have not done outputting trees. So we need to describe how to input lists. So that's one thing. And then how to output data trees. Well, actually, I need to describe the data tree structure in Grasshopper. So that's another thing. And then how to output data trees, and then how to input them, and then how to input data trees, and then example should be, for example, mass addition of components of numbers. So that could be one to do. That could be an interesting, because you take a list and you just output also a list as well. And now a number and a list with all the partial results. So that could be one. Describe the data structure in Grasshopper, how to output data trees, and then for that, replicate an example. Which example could we replicate for that? So let me look up at, let me fire Rhino, preview components. I wonder which of the ones we have, a grid of points. Could that be interesting? Do we have a grid of points? Okay, utility components, vector components, construct vector, vector to the point grid. Okay, yes. So this one, because we use data trees here. Okay, and then we use that, and then nerves, whatever nerves, blah, blah, blah. Well, divide the surface. This maybe it's a little too long. Data components we can get. So we can use how to output data trees and then just do example of point grid and how to input them, and then example of what, for example, tree info. What, tree info, maybe? Tree info, I don't know. I'll take a look at that. And I wonder if after that we want, I think that's pretty straightforward. I'm not sure that we need to actually do examples or do a file, a video here. I don't know that we need to do a video with examples. It's not really that difficult or that different. Okay, custom previews versus management test. Okay. So so let's start with that. And then we're going to start with that, and mass addition is going to be in arithmetic, or for example, or numerical sequences. I don't know, in utility components. I think we're going to do that in utility components. All right, so how's everyone doing? Let me open Visual Studio, Pcam Grasshopper plugin. Divide curve and generates a list. Okay. Okay, so how do I start the video? Maybe I should start with Rhino. I'm gonna start with Rhino, perhaps. Now we're going to do this. So maybe I can talk about addition, mass addition. The result, partial results here. Okay. Alrighty. Mass addition. What was the last video that we did? Icons and our first components. Okay. Okay. All right. So let me start here then. Hello, this is Jose Luis here at Parametric Camp, and welcome to another video in this series, Advanced Development in Grasshopper, where we're going to take a closer look at how to manage data structures when we are developing native plugins for the Grasshopper environment. And what do I mean by data structure? So if you are familiar with the Grasshopper environment, you may already know that we can work with individual points of data, like for example, adding two numbers and getting another number as a result. But we can also create sequences of numbers that are stored in data structures that are referred to typically as lists. But Grasshopper, on top of that, has a particular data structure that is called the data tree, which is basically a combination of multiple lists that have a certain order and a certain structure within a larger superstructure, if you will. We've talked about this structure previously in previous videos. And we've also seen in previous videos how to do lists and how to create data trees inside of Grasshopper using C# scripting. In this video, and I'm actually going to point to a card that will be popping here somewhere in the corner, and it will be in the description of this video where you can find more information about that. What I would like to cover in this video is how to, in native development, how to work with lists of data as inputs and as outputs, and at the same time how to handle data trees natively in Grasshopper in development, because when we develop native plugins, data tree structures are slightly different. Okay, so examples of this are, for example, if I take a list of numbers and I input that list of numbers, then I can take the whole list and make operations that look at the full list altogether. And I'm not liking where this is going. I think I'm going to start over again. I was not liking that. So I think I went too much into what data lists are and data trees are. And that was unnecessary, because if someone is watching this video, it's already from the playlist and they already know what lists and data trees are. Okay. And maybe I don't need to explain. Maybe I don't need to explain. I get much into this. All right. Okay, let's try again. Hey, Sujai, welcome. Hello, this is Jose Luis here at Parametric Camp, and welcome to another video in this series, Advanced Development in Grasshopper, where I would like to take a closer look at how to handle data structures when we are developing native plugins in Grasshopper. Because as you already know from previous videos, Grasshopper allows you to work with individual points of data. So for example, you can right click here and say I want item access, so one element at a time, or you can work with lists as an input so that you can take a look at the full list of elements that are coming in. But also, as you already know as well, Grasshopper has this particular data structure called data trees, which is basically a collection of lists within other lists and with some additional metadata such as the name of the branch that those lists are contained. This is very handy for many operations, and we have seen in previous videos how to, using C# scripting, how to work with lists and to work with data trees. There will be a card popping up, hopefully, in the corner, pointing to previous videos where we have seen that. So in this video, I would like to take a look at how to handle lists and how to handle data trees, especially because data trees are a little different than what they are when we do C# scripting. Okay, so for example, in the previous examples, like for example, when we were developing the divide curve component, you could see that in order to output, instead of one item at a time, to output a list of items, it was just as simple as changing the access parameter of the outputs that we had here on the output. All right, it was just as simple as that. And then keeping in mind that the only thing that we need to change when in our server instance is that in the DA element, so in the data access element, instead of using the set data method, use the set data list for the output. Okay, so what we're going to do in this video is we're going to take a look at how to take a list of data as an input, and then we're going to do an example of that, and we're going to move on to data trees. So let me show you an example of how to take lists as an input and work with those. I think what we're going to do is we're going to do an example where we're going to replicate the mass addition component. The mass addition component is a component that takes a list of numbers and then adds them all together, creating the result of all the numbers together. And then it also gives you partial results of those additions. Okay? So let's take a look. Let's write the basics of a mass addition component natively. Okay, and then what we're going to do now is, how am I doing battery-wise? So what we're going to do now is, okay, mass addition. As we've done before, what I'm going to do is I'm going to go to utility components and add a new item that is going to be a subset of the template empty grasshopper, and I'm going to call this mass addition component. All right, and then mass addition component, and this is going to be mass add, and then this is going to be mass addition without the component, and then the description adds a collection, adds a list of numbers, and then the category is going to be utilities, correct? That's what we, no, the category was pipcamp and the subcategory was utilities. All right, you need to keep this in mind. I keep forgetting all the time. So in the input parameters, what we would like to do is I would like to take a list of numbers. So this is just going to be as simple as what we did in what we did with the output, which is using the P manager object. I would like to add a number parameter. I'm going to call this numbers, and then the nickname is going to be I, just to make it similar to the native component. The description is going to be numbers to add, and then the parameter access, the only thing that I'm going to do is I'm just going to set it to list instead of an item. All right, it's just as simple as that. And then the two outputs are going to be R, which is going to be the result, and PR, which are going to be the partial results. So I'm going to say P manager add number parameter, and then R, which is going to be the result, and then the result as the description, and then this is going to be an item, because from a list, when we add them all together, we just get one single number. And then I'm going to copy and paste this, and I'm going to say PR, and this is going to be partial, and this is going to be partial results. And then this one, instead of an item, is going to be a list, because I'm going to have a list of numbers representing those partial results. So as you can see, managing inputs list is just as simple as changing the access parameter, but also remember when we do this pattern where we predefine the variables that are going to contain the input data and then we fetch it from the data access object, the only thing that we will need to do is that this, instead of being a curve or an integer, or it will have to be a list of all those values. So here, what I'm going to do is I'm going to define a list of doubles that I'm going to call values, and then I'm going to initialize to null, for example. And then what I would like to do now is I would like to say if I did not get a data list, in this case we do not use get data, we use data list. If I could not get data list in parameter 0 and that I'm going to pass to values, then please return. All right. And I think the error that I'm getting here is that I don't need the ref keyword because this is not a primitive value anymore. this is a list, which is a reference value, so I don't really need to do that anymore. And then that's it for taking the inputs. So now here I can just write the algorithm, and the algorithm is going to be fairly simple. So I'm going to create a value that I'm going to call partial, that I'm going to start at 0, and then I'm going to write for each loop. Do I need a regular for loop? I don't think I do. So for each, that will be in values. I am going to take, and I'm going to define also another list that I'm going to say this list is going to be a list of double, and that's going to be partials, and I'm going to initialize it to empty, right? Beautiful. So what I do is for every value on the list that I'm loading, I say to partial, I want to add this value, okay? And whatever the value of partial at that point is, I want to add it to partials, the list of, and this is a little confusing. So how about I rename that to, oh no, sorry, this is not partials, this is partial, okay? You see, I'm already confusing myself. That was a poor choice of names. So I'm going to call this P, okay? And then the outputs are going to be DA. I'm going to set the data, just one single element in the first output, that was the result. And I'm going to set the value of P, which at that point has all the values added together. So that's one thing. And then DA, the second one, what I'm going to do is I'm going to set a data list. We've seen this in the previous video, where I'm going to set the list of partials that I have created as I was adding the numbers together. All right. Okay, this looks to me like it should work. So I'm going to close Rhino, and then I am going to start a new, excuse me. I'm going to start a new Rhino that has my plugin loaded in. And I am going to open Grasshopper, and I guess it was the components that I had. Yes, I had components here, and in PC I had utilities, and oh, it's not showing up. Why is not showing up? Oh, I think I have the name, I have it wrong, for example, for some reason. So, but let me just say mass addition. So for example, let me plug in here the series, all right? And then you can see that value cannot be null. What is going? Parameter list is a null reference. Get data list can only be called with a constructed list T. Interesting. It looks like maybe by doing null, it's not working. I cannot assign that data to this data, to a non-initialized. Let me say that again. I cannot assign a list to a non-initialized list. I didn't know that, or I didn't remember. Utilities. Okay, so that was the type of utilities. So maybe then let me just initialize this to a new list that is empty, and let's see if that solves the problem. I'm going to initialize this. I'm going to open Grasshopper again, and then I'm going to open components, and then you can see that now this works. So as this is working right now, I'm going to copy partial here, and you can see the partial results, and then you can see the full result is here. So that would be 75, and this is the result. And let me compare that with mass addition, and let's see if that is the same. So I'm going to plug that in here, and the result is 67.5, and the partial results look also the same. Okay, so it looks like we're good. And now utilities, add numbers, mass addition. So this is here. All right, so this is looking great so far. Beautiful. So I think this is already good. So data lists, we know how to output data lists, and we know how to input data lists as well. It's just a matter of making sure that the inputs and the outputs have the right parameter access, and that we are working with native C# lists. We don't really have to do anything around this. So now let's take a look at how would we work with data trees instead of simple lists inside of native Grasshopper components. All right. Okay, Richard, Tim, good to see you. Welcome. So what are we doing next? So we want to take a look at data trees. So I think the first thing we could do is we could create, I think I'm going to try it first. So we're going to do, I'm going to save this. We're going to create, what are we going to do? We're going to create grid sorting, grid points in a grid. So I'm going to take, let me take a look at what we did originally. Let me take a look. And I'm going to make a video about starting Grasshopper right away. I'm going to make a video about that. Maybe we can make the video now. Error handling. Oh, this is breaking. Not good. Bong. Rhino just crashed on me. Okay, so let's try again. Up. Okay, we're good now. And I would like to take a look at the point grids. Point grid here. I'm going to keep that, and perhaps this is something that we could start the video with. So I'm going to take a look at point grid, and I'm going to say, remember, in C# script we have data trees, which I don't really know why we don't have that in the Grasshopper SDK. Let me double check, because I've always done it in a different way, but maybe I am being dumb. So do we have data tree? Data tree constructor. The data tree class implements basic Grasshopper data in an easy to use class. It's used primarily in a scripting component. If you're using SDK, you should consider. All right, so I guess this is. So I guess I was doing it right. So I was not using data trees. Which actually, it's a pretty good point to bring up. It's a pretty good point to bring up as I'm talking through this problem. Exactly, I know, Victor. That's what I would like. I'm gonna make a video about that, I think. I'm gonna write it here. Where should we do this? Error hand. Should I do this here? 5.7 auto start Grasshopper on development. Maybe we can just do it here, literally. Okay. Okay. So I guess this is a good thing to talk through. And yes, and I don't need that here. Okay. Beautiful. So let's start then. If you remember from our previous videos, Data3 structures are this particular structure for data, that was redundant, that Grasshopper has, whereby you can have a structure that contains multiple lists in an ordered way with this additional metadata in the form of branches, indicating which giving basically names to each one of the lists. We have previous videos for that. We're not going to get into that again. But if you remember, the way we did this when we were doing C# scripting is by using this particular class that is called the data tree, that allowed you to specify the type of data that the data tree was going to be holding. And then it had specific methods for adding data to particular paths or particular branches, etc., etc. So this method using the data tree class is very similar to what we're going to do inside of native Grasshopper components. But we're not going to be using data tree because the data tree class was actually designed primarily for scripting components. So if you look at the Grasshopper documentation, the SDK, you can see here implements basic Grasshopper data tree functionality. It's easy to use. It's mostly for scripting components, but if you're using the Grasshopper SDK, so what we're doing ourselves, which is writing native plugins, you should consider instead using the GH structure class. If you go to the GH structure, it's basically the same thing. It's just that it contains many more methods and much more functionality that can be used. It's basically perhaps like a superstructure or like a lower level structure. I'm not sure which one to call it, but it basically has more stuff and more refined access to many things. It just requires a little bit of management from our side, but that's fine because we're at a level where we can handle that management, and we actually want that management so that we can have fine control over what we're doing. So the only difference will be that instead of doing things the way we did them with the data tree class, instead of that, we will be using the Grasshopper structure class in a very, very similar way with a few minor changes. So why don't we go ahead and we try to replicate this component, the point grid. What I'm going to do is I'm going to copy this whole thing so that we have it as a template to look at, all right? And I'm going to close Rhino and everything, and I'm going to create inside of vectors, I'm going to create a new component that I'm going to call point grid component, all right? And before I lose my stuff from the clipboard, I'm just going to paste everything. It's not going to work. I just want to have it there for reference so that we can look at it when we get there, all right? So the name of the component is going to be point grid. The nickname is going to be point grid. For example, the description creates grid of points. For example, the category is going to be pcamp, and the subcategory is going to be vectors. I forget construct vector. Yes, vector. The subcategory is going to be vector. All right. Let me take a look. Oh, I forget what the input parameters were. So I would assume that it would be something of the kind, the number of elements in the y direction, the number of elements in the x direction, the gap in the d direction, and the gap in the y direction, and the starting point, perhaps, as a point. All right. So let's start with that. So I'm going to say pmanager.add. I'm going to add a point parameter, and I'm going to call that the start, and then s as the nickname, and then starting point, and then this is going to be an item. So I just want one point to start working with. Then pmanager add point. I'm going to add a number that is going to be an integer, because I'm going to say how many elements in the x direction and how many elements in the y direction. I'm going to call this count x, and then number in the x direction, number in elements in x, for example, and then the Grasshopper parameter access is going to be also of the type item. So now I'm going to copy and paste, and now it's going to be in the y direction, okay? And then the next one I'm going to do is pmanager. This is a little tedious. Pmanager.add numbers, and then this is going to be a step in the x direction, all right? And we were calling that, what were we calling this? Dx. So we're going to call this dx, and then distance in x, for example, and item. And then step in the y direction, dy and dy. Okay, beautiful. And I believe that the output is going to be just a collection of points. I forget if we had something else. We can take a look at that later. But remember, so I'm going to add points, and this is going to be p. The name is going to be the points, and then the nickname is going to be p, and then grid of points. And then parameter access, the only thing that we need to keep in mind now is that what we want is to output a tree of points, because remember, for this grid, what we're going to do is we're going to have one branch for each row of points that we are designing here. Okay, so I'm going to do 3 here. Beautiful. And then just to be consistent with what we did before, I'm going to keep S, capital S, dy, and x and y as the names of the variables. So I'm going to start and say double dx equals 0, double dy equals 0, point 3d s is going to be a point that has not been defined, so it's going to be unset, and integer number in the x direction is going to be 0, and number in the y direction is going to be 0. And then if da dot get data for parameters 0 and reference x, if this didn't work, then return. And then I'm going to do that for number 1, and that's going to be an x. I'm going to do that for number 2, which is ny. I'm going to do that for number 3, which is dx, and I'm going to do that for number 4, which is dy. All right, beautiful. So at this point, I have all my data correctly loaded and available for me. So what I would like to do now is I would like to basically be able to create a similar algorithm to the one that I have here. So how does this work? Well, it turns out that instead of using Data3, as I said, what we can do is we can use the Grasshopper tree structure. So what I'm going to do is I'm going to type Grasshopper underscore structure. Is that? Yes. And you can see that I am not getting an autocomplete for this class, which is strange. Why is that? Well, if we look at the Grasshopper structure class, you can see that it belongs to the Grasshopper kernel.data namespace. And if you think about it, if you look closely up here, we do have the Grasshopper kernel namespace, but we don't have the sub namespace loaded in there. So what we can do is we can say, well, we have the Grasshopper kernel.data. So we have the Grasshopper kernel available. So what we could do is we could just write data dot and then Grasshopper underscore structure, but that's actually not working for me. I'm not sure why. So what I can do instead is probably the easiest way, is just say, well, I want to use also grasshopper.kernel.data. All right. And then once I do that, now I will probably have available here my Grasshopper structure. And then inside of the square brackets, I will need to define what type of data I'm going to take. I will get to that in a second. So I'm going to say, I'm going to define this, is going to be points, and I'm going to create a new data structure that is going to be empty. Okay? Now here I get the t parameter as a default. To mimic what we did before, I could say, let me say that I want point3d to be the class or the type that this Grasshopper structure is going to hold. However, we have a problem there. And the problem is that Grasshopper structure as a class is actually very specific about the types of data that it can take. And it turns out that because Grasshopper types, because Grasshopper components actually do a lot of processing of native types into custom Grasshopper types that then have all this additional information that helps them know how to convert themselves into data that can be transferred through a wire, or convert themselves into data that can be serialized and saved into a file, etc., etc., it turns out that the Grasshopper structure doesn't accept plain Rhino common data types, just like Point3D is. If you look at Point3D, you can see that it's coming from the Rhino.geometry namespace, whereas Grasshopper structure is coming from the Grasshopper namespace. So there's a mismatch there. And if you look at documentation, Point3D cannot be used as a parameter, blah, 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 because there is no voxing conversion to the subtype I interface Grasshopper Go. This is a really weird to say. This is a really weird way to say that the type that you need to use here cannot be a Rhino common type. It has to be some kind of point type that belongs to the Grasshopper SDK. And the way that we're going to do that is that we're going to use the Grasshopper type, which is, let me actually look that up, Grasshopper Point, and see where that is. Grasshopper Point is inside of Grasshopper kernel and types. So what you can see here is that Grasshopper gives us wrappers around primitive Rhino common types where Grasshopper adds all this additional information that it needs for data to flow correctly between components, to show up in an output, in an input, etc., etc. And you can see that there's actually wrappers for everything. There's actually wrappers for circles, B-reps, curves, but also even for primitives. We have wrappers for an integer, for a number, for simple points, for a lot of stuff. So what this means is that whenever we want to create data trees of a particular Rhino common type, we will have to find the matching Grasshopper type inside of the kernel types namespace. So for example, if I write here Grasshopper Point, you can see that it's also not showing up, and that is not showing up because that belongs to the Grasshopper kernel types namespace. And as I do that, you can see that now this shows up, and now this shows up, and now I can store these points in my Grasshopper structure. So with that, we are good. And actually, most of the rest of the algorithm should work pretty similarly. So if I uncomment this, you could see that for the most part, everything is working well. So I can do my for loop, my computation, I can create a path, etc., etc. I can create my Point3D. The only problem is that I cannot add, I'm getting an error when adding this point that I just created to the Grasshopper structure. This is because, again, it's a problem with types. What I'm trying to do is I'm trying to add a Point3D, remember this is coming from Rhino Common, to a structure that is designed to contain Grasshopper points coming from the Grasshopper SDK. And the problem is that Rhino doesn't have an automatic way of converting from Grasshopper from Rhino Point3D to the native Grasshopper point. So how can we do that? Well, if you look at the Grasshopper point, if you look at the Grasshopper point class, you can see that in the constructors you can create empty Grasshopper, blah blah blah, empty Grasshopper points. You can see that interestingly there is no component that there's no constructor that allows you to create a Grasshopper points from XYZ coordinates. This is a very clear indication that this class is not actually meant to be a class to work with or to operate with points. It's a class that is meant to wrap native Rhino common types and then just add a lot of metadata and additional information. So actually what I can do is I can initialize a new Grasshopper point with a Rhino common point, which is what I'm about to do here. So what I can do is I could say Grasshopper, I'm going to say Grasshopper.point JHP is going to be equal to a new Grasshopper point from P. All right. And then this is the one that I could feed into my into my Grasshopper data structure. Okay. And what else? This is not working because points doesn't contain a definition for adding. Okay. All right. What else? So, so how did we add? I forget. Yes, it was appending. Mm-hmm. This error is caused by the fact that if we look at the documentation of the Grasshopper structure, it turns out that it doesn't have on its methods, it doesn't have an add method, just like lists do. It has this method called append, which does a very similar thing. It just adds whatever type to the tree and with optionally a path to target where that object should go. So it's just basically a semantics problem. I wonder if David Rotten, when he was designing this, he thought that having add as a name would be confusing between data trees and lists. So he decided to change the name to append to make sure that people were aware that this is not a list anymore, that this is a data tree. So I can append, and then I can append my Grasshopper Point object. And let me see how, if I were trying to append the point 3D object, I would not be able to do it. I need to be the Grasshopper Point object, all right, to this particular path. Or if I wanted to be perhaps a little more quick or elegant or fast, I could just bypass directly creating that variable and just create simply a Grasshopper Point on the fly as I add it to the tree. And literally, this is it. That's everything that we need to take care of when it comes to data trees inside of native Grasshopper components. The idea that we don't use data trees and the idea that we need to find the corresponding Grasshopper type that we can use to wrap the native Rhino common type that we will typically be working with. So now what I can do is I am ready for generating the outputs here. So let me say that da.set data3 as an output. So this is a new one on position 0, and that the tree that I want to set out is going to be PTS. All right. Beautiful. Where was this going to go? It was going to go into vectors. So let's see if this works. What do you think? Is it going to work? Is it going to work? Let's give it a try. Okay, my Grasshopper went on the other screen, and then here now under vectors I have point grid, and let me open the other file. I'm just going to copy literally the other file, the data from the other component. Oh, and it crashed. I've been having this problem before where when I'm developing, I can't really open other files. That's kind of sad. So let's just replicate it manually. Give me a second. Okay, so here I'm going to do so I'm going to construct a point, and this is going to be I'm going to do this, and then this, and then this, and then 0, this 0.5, and this is going to be 5, and then that's going to be the starting point, and then the amount of elements in one direction is going to be 10, the amount of elements in the other direction is going to be 10, and the gap size is going to be something, for example, here and here, and okay. And I'm going to turn this off, and I'm going to turn this off again. Beautiful. So here we are. This is the point grid component we just developed. I plugged in a point. I plugged in a bunch of numbers to control how many elements in one direction or the other. It looks like if I turn the pre-visualization on, this is working. I can control the direction in the gap in each one of the directions. But most importantly, is this a data tree? So beautifully, what you can see is that what I'm getting out of this component now is this list of lists where I can have now, for example, I have 10 lists, which 2 points each one of them structured as a data tree with different branches, etc., etc. Okay, so beautiful. That was it. So this is this is all basically that you need to know about working with data trees inside of native components. All right, you can create empty data trees like this. You have to make sure that you wrap the data tree, the data inside of proper Grasshopper types, and you just have to output it with the set data tree method and make sure that the output has the correct parameter access as the tree. Okay, and similarly, if we wanted to work with data trees that come into the component, it would be very, very similar. So let's see let's take a look at a really quick, let's take a look at a very quick example of how to do that. Okay, so I'm going to do that offline. I'm going to do that offline. If this doesn't crash, which it did. Okay. And I'm going to do it offline. Ooh, you don't wrap them, Victor. You just use objects. Or you create your own custom IGU. You create your own sub-extensions of the Grasshopper data types using the IGHGU interface and wrapping your own data. You do that here. So here with IGHGU. So this. So no, wait. This interface. So you create a data type of your own. So for example, Grasshopper underscore my data type, and that data type must implement the interface Grasshopper GUI. Okay. Okay. And data tree. Where were we? Preview. I was going to do this one, the tree info. So I'm going to copy this. And I wonder if we have access to all that information. So let me try that. So let me do that. I'm going to do this offline, data components. I'm going to create here, I'm going to add a folder and I'm going to call data comps, all right, and it's going to be tree info component, and I'm going to add a new one that is going to be tree info component. So we may actually want to make a video about that, Victor. That's a good point. I'm going to write this here somewhere. To do implementing our own data types using IGHGU, I guess. That's advanced actually. I wonder if we can do that when we do external libraries. I wonder if we can do that. That's a good one. Tree info component. So that's going to be tree info description dumps get info from the incoming data tree. Okay, category, that's going to be pcamp, subcategory data. Register input parameters, so that's going to be t as the tree. So that's going to be pmanager of the type add generic parameter. It doesn't matter what this is. And this is tree. This is tree. And input tree. And the access is going to be of the type tree. So that's one. And the output is going to be, all right, so we have this. The algorithm sentences, the output is, it's actually going to be, so, all right, so pmanager, so we had topology, description, paths, branch count, and item count. And this was just not, okay. All right, so pmanager, so I'm going to add a string, add text parameter. That's going to be topology, and it's going to be top, for example, tree topology, and then data access tree. Okay, so what else? We have description, pmanager, add text parameter, then description, that's going to be the description. This is what's bad about, oh, this is not tree, sorry, this is just an item actually. And description is going to be the type. This is what's bad about developing Grasshopper. It's just very tedious. You have to write a lot. If you want to do a good job about documenting everything, having text, highlights, all this stuff, it's kind of, yeah, it's kind of a lot. So pmanager dot, I wonder, are there add path parameters? Add a data path parameter to the output list of the, yes. So that's going to be paths. That's going to be p paths, and then Grasshopper. This is going to be a list, and then pmanager dot add integer. That's going to be branches, and this is going to be b branch count, and then that's going to be an item. And then pmanager add integer, also an integer. I'm going to call this items, and I'm going to say this, and then item count, and then Grasshopper X. That's going to be also an item. All right, beautiful. So what am I doing here? So how are we picking up a generic tree? That is a good question. I've never done this. Good thing we're doing it offline, because I have no idea what I'm doing right now. Okay, so point grid. Let me take here the data types. Let me just take everything. I'm going to take here everything. I'm going to overwrite it here. And then Grasshopper structure is going to be, can I do object? I guess, is it generic? We're going to need to find a generic. Hi, Soshli. All right, tree is going to be a new. Okay, and I guess we cannot do object. There is an implicit conversion between objects, so I guess, can we do Grasshopper goo? So can we just implement generic? Because we really don't really care. I guess we can. and we're going to call this T. Okay. And then this was the algorithm. And I guess branches gives me a list of lists, guess a list of all the data arrays in this. So if I do this and then I do count, it should probably work. And then branch. What is the problem with branches? Branches cannot be converted from system generic lists. It's an I list. Oh, what is going on with this? Gets a list of all the data. Okay, so a technique that we can use to clarify what's going on here is, let me get this. So the problem is that the conversion between this and this is not working. So I'm going to use the implicit type, and then I'm going to say, I want to use the explicit type. So this is giving me a list of IGOO objects. So the problem was being that this cannot be object, it has to be IGOO. And then we have this, and then the outputs are going to be what? Topology, so that would be da.set data, I forget, set data, yes, at 0, and that's going to be topology. I know, so t.topology description, so that's one. da.set data list, so one is going to be sentences. Do I have sentences? Yes. Sentences. So da.set paths, so data list, and t.paths. Yep, that works. t.paths and da.set data branch count. That was just 1, 3, and then that was t.branches.count, and then da.set data. And number 4 is t.data count. Data count. Do I have branch count? I don't have branch count, so this is just branches.count. All right. So, and let's see if this works. Yo, Carl. And let's see if this works at all. So I'm going to oh no, that's not what I wanted to do. That's not what I wanted to do. Okay, sorry. Maybe it's just that one file that doesn't load while we are on development mode for some reason. Components, all right, and then here we have Data3 info, topology, empty data, what? Branch count 0. Why is this not working? Uh-oh. All right, folks, something is wrong. Topology, empty data. I wonder what is going on. Am I not? Oh, I am not loading. All right, I did not load. I did not load. That was very smart. I did not load. Look at what happened. I just didn't load if da dot get data3 from 0 and put it inside of t, then return. I was just not loading the data. And I got an error. This has to be okay. All right. Very smart, Jose. Very smart. And I believe Grasshopper has crashed. Oh, what's going on today? I'm having a really bad March. My laptop decided to stop working. This computer... What just happened there? This computer is also doing strange stuff now. Yeah, what is going on here? Okay. Yeah, and why are the tabs not... Oh, okay. Description. Okay. Okay, for elements. Okay, so I'm going to show this and this, and the paths are blah blah blah, and then branches and the amount of items. Okay, beautiful. So I think I'm ready to explain this. You can set build events so you don't have to load Rhino and Grasshopper every time using Grasshopper reload assemblies. How does that work? Grasshopper reload assemblies. Grasshopper. I don't have Grasshopper reload assemblies. I think they discontinued that that was available in Rhino 5 or Rhino 6 or something, but I think they stopped that in Rhino 7 because it was just too messy. Is that what you're talking about, Carl? I used to do that, but I think they discontinued that. Okay. Okay. All right. So I'm going to take this here. I'm going to I'm going to show the example of... I didn't start doing anything before, right? No, I didn't. It's still in there? Where is it? Grasshopper. Grasshopper. Damn it, Grasshopper. Grasshopper. Reload assemblies. Successfully. So they hit it. Interesting. Okay. So let me try that. So I'm going to, so right now, components, this is working. I'm going to save this. This is working. Okay. So what if I rebuild the solution and I reload this? So Grasshopper reload assemblies. It's really reloaded, and then I reload it, and I recompute it and it's not happening. Load Grasshopper developer settings, then ensure you've checked memory load. Grasshopper developer settings. I do have memory load. It won't autocomplete just a shortcut, something like that. I can have a Grasshopper file open. Okay. I'm going to save this. I'm going to close Grasshopper. I'm going to Grasshopper developer settings, Grasshopper reload assemblies, Grasshopper reload assemblies. It's there now. Components. You are right. It reloaded the thing. Interesting. I like it. That's quite good. Thank you, Carl. I did not know that thing was still there. Okay. I wonder if this is something that we need to incorporate somewhere. I'll think about that, but maybe we can talk about that in the actual. I kind of think that for beginners, it's still better to have the whole turning it on and on, because at some point I also want to talk about the idea of launching Visual Studio and having it associated to Rhino so that we can do breakpoints and that kind of stuff. But yeah. Well, make sure the build is not too much. I'm not making a lot of money with these videos. Yes, Tim, we will do the no splash thing, and we will do customizing our build events. I just thought that would be a good video to do. We may actually do this today. Okay, so let's finish this video, which is, we are here. So I said I would like to show the other video. I would like to show the other file, preview components. I'm going to close this one actually, and I'm going to use preview components. So I'm going to talk that this is what we're going to replicate, and then I'm going to go here. I'm going to show that I have all the inputs, the path, etc., and then that this is the algorithm, and then I'm basically going to do what I did before, which is just okay, all right. Okay. So for instance, let's say that we wanted to replicate now the tree info component that we developed before. If you remember, it's just a component that takes any tree, a tree that is generic. It doesn't have to have a type, because it's going to just fetch metadata from that tree. And then it does a little bit of like going through the branches and creating some sentences, etc., so that it can output some information about the topology of the tree, how many branches contain how many elements, the paths, and then how many branches the tree has and how many items are in total in that tree. So what I've done is I've gone offline and I have started this. I created a data components folder, and inside of it I created a Grasshopper component called tree info. I added the metadata, and then what I did was, and this is interesting, is that for the input, I did take an input of the type of the parameter access tree, so that I can actually get the full tree with all the information. But in this case, instead of adding a point, a number, a curve, whatever, I use this generic input, which means that we don't really care about the type of what's coming into the tree. We actually, into the input, we actually care that what is coming in has to have the structure of a tree. That's only what's important for us right now. Generic is the type that we use for things that may have any type, and that us in the solver will be the ones who will handle which type that is, if we actually care about that. And then in the outputs, if you remember, I have added text for topology, text for parameters. Some of them are items, some of them are lists, integers, etc. And I've added an output of the type path, because path is a Grasshopper type that is also quite important. All right. And then I have copy-pasted here the algorithm that we had in the C# script component. So what I'm going to do is, I'm going to do what we usually do, which is, first of all, I'm going to fetch the data from the input. In order to do that, I have to predefine a data tree that I'm going to use to take that input data and put it in there. So I'm going to define a variable called Grasshopper structure of some type, and I'm going to call this capital T just to be consistent with the code that we wrote before. And this is going to be a new Grasshopper structure of some type. All right. Similarly to the problem that we had before, because we want a generic type, we don't care if this is points, vectors, whatever. I might be inclined to say, maybe I can just use the generic object type as a placeholder for any type of information. Okay. But it doesn't work because, again, Grasshopper structure, the Grasshopper structure class requires that whatever data it implements, it has to have some additional things that are not part of the object class. So that's why when we were looking at the wrappers, so let me, well, for example, the Grasshopper, if we were looking at Grasshopper Point, if we were looking at the kernel types, you can see that all of these are the wrappers that were designed for taking Rhino common objects and wrapping them for Grasshopper. However, there is no Grasshopper object wrapper. Actually, there is a Grasshopper object wrapper. I had no idea that this was the case. I just literally discovered this right now. But what I wanted to go to is that instead of using one of these types, a technique that we can use is, if we look at the types, for example, integer, we can see that integer actually inherits from this thing called the Grasshopper GUI. Or if we go to, for example, point, we can also see that this thing is also coming from some kind of geometry GUI, IGH, etc., etc. These were probably not great examples, but I guess what I wanted to say is that most of Grasshopper native data types, they all inherit or they all implement this other interface that is called the iGrasshopper GUI, which is an interface that is designed for Grasshopper data types to implement a set of functions that they need to work in Grasshopper components. What this means is that every single Grasshopper type implements the Grasshopper GUI interface. And because that's the case, the Grasshopper interface is kind of a common structure shared among all data types. So in a way, we can use that as a substitute for a generic type that is a placeholder for all possible Grasshopper types. So what I can do here is I can say, well, instead of that, instead of object, let me just make sure that whatever you store here has to be something that implements this interface. And then all of a sudden that becomes a generic type in the Grasshopper subworld, if you will. The next thing that I'm going to do is I'm going to use the typical if da.get data tree. In this case, if I didn't get the input from 0, that I'm going to store in the parameter t using the out keyword, then please return. I don't want to keep executing this. Okay? Beautiful. And then after that, the algorithm is actually going to be pretty similar with a couple of changes. First of all, it turns out that the Grasshopper structure class doesn't have a branch count property. What it does have, though, is that if I go to d.t and I type branches, it does have a list of branches that I can then access, for which I can access the amount of elements that it has. So instead of being one property, it's kind of a property that is hidden behind another property. All right. So I can access the list of branches, and from that list, I can get how many they have with the count parameter. And then here, I am having the similar problem that I was having here before. Because branches is taking a list, is returning a list of Grasshopper GUI interface objects, those cannot be converted immediately to object. So what I need to do here is I can say, well, this has to be now an interface Grasshopper GUI object, and everything else is just the same. And then for the outputs, the only thing that I need to do is just change these, which are, if you remember, our typical outputs, and then change them to something that looks like this. So set the data in 0 to T topology description, the sentences, the paths, and similarly, I don't have branch count, I have branches dot count. Okay? And if I run this and I execute my plugin, so let me run the whole thing, we should probably be on a good track. Let me see if that is true. I'm going to open the components file that I've been using to debug, okay? And then you can see that I already placed here so I have this one, and I already placed here an example from that I did offline, and you can see that this component is now giving me, for this branch, the one with the grid points from before, it's now giving me the topology, is giving me a description of how many elements each branch has, all the paths, the amount of items, and the amount of branches and the amount of items in the tree. So beautiful. This was an example of how to use the Grasshopper tree as data structure as an input. Remember, the only things that you need to remember is at the inputs to use the tree parameter access, and then make sure that you use the Grasshopper structure class as we've done before. And if your tree has to be of a particular type, like a tree of points or a tree of curves, then you're good by just using the Grasshopper point, the Grasshopper curve class. But it is just generic because you're going to be working with the tree in general. The GUI, the Grasshopper GUI interface, can be a good solution as this big bucket where to place your stuff. Okay. Beautiful. And with that, I believe this is what I wanted to cover in this video, which ended up being a little longer than I thought, but I also hope that through this you have gained some insight into more advanced development techniques, the relationship between classes, interfaces, inheritance, and also a new way of understanding how data trees work inside of Grasshopper. Okay, so we're gonna leave it there for this video. Thank you very much for being here. If you liked what you saw and if you learned something, then maybe hit some likes, subscribe to the channel, all those things, etc., etc. And let's move on this playlist, Advanced Development in Grasshopper, to the next video, which at this point, I'm not sure what it is, but we're probably gonna find out in the next video. Thank you very much. Bye-bye. Beautiful. I'm going to take a 1-minute bio break. I will be right back. Give me a second. Okay. Alrighty. So, okay, so let me write myself a few notes here about what just happened. So we have data, Grasshopper structures, card data trees in scripting. Oh wait. Okay. Beautiful. So perhaps this so error handling. Yeah, I don't think we're gonna have time to do auto updates today. So I think I'm just going to do 2 more videos, which are hopefully gonna be short. One is gonna be error handling, and the other one is going to be how to like click here, start, and then have the thing open Grasshopper right away, and then open a particular file that we're working with Grasshopper. Um, mm-hmm, mm-hmm, mm-hmm. Yep. Auto start. Okay, and then for error handling, how can I do error handling? So what is a good example of error handling? Index out of bounds. Remove first. Where do we have any? Do you remember any component where we had warning and warning, where we had both a warning and an error? I don't remember. Probably in get branch. Warning, index out of bounds. Warning, this is a lot. Index out of bounds. Well, maybe we can do more like something where instead of just stopping using return, what we do is we throw an error message or like a warning saying, hey, we didn't get enough data, just using 0 as a default. Or something like that. That could work. Divide by 0. Huh? That could be 2. I just want to find something that like a component that we've used already. For that. What could be something with a default value from the examples that we've seen so far? So, because if I disconnect this, okay, it uses 0, 0. Because that's point grid. But what if I were to load components? What if I disconnect this one? It gets an error, input parameter failed to collect data. Oh, but then I'm going to get into optional parameters or not. That's going to be a lot. I don't know. Which one should we use? I just want it to be simple and clean and lean. I don't want to get very complicated. Well, maybe this one, remove item. Yeah. You could just set defaults right in the P manager inputs in the end. I know, yeah. Which I haven't covered actually. I think you have, yeah, we haven't covered that in the videos actually. You might have a good point, Tim. Okay, because what if I don't do this? Let's say I don't do this and I run the plugin and I don't pass info to the component. Fine. And then if I do that and I disconnect, it failed to collect data anyway, so it stops executing anyway because it doesn't have a default. Okay. So, but we can do a default for the tree because it's kind of useless. So what would be a good example? What about vectors, construct vector component? What about that one? And here, so maybe the construct vector could take default values. Okay, that could be an interesting. Okay, so let's do that. Let's do that. Okay. Yeah, I think that's a good idea. Okay. All right. So, so then this is going to be called error handling. So let me try what I'm thinking of doing instead of just in case. So that's going to be, let's add some defaults here. And then let's say if da dot, let's say if da.data or da get data or this thing. Oh my god, I'm a little clumsy right now. If none of this, and then so this dot add runtime message, and then runtime message warning, and then using default inputs. Okay, and if I run this, And then I do components, and then I drop a vector. I am not getting any error because I am passing in default parameters, which are 0, 0, 0. So not a good example because I did get data as part of the defaults. So then why we were using this in the first place? I forget it. So not a good example. So maybe we can make a video on just this, you know? So maybe we just don't need any of this at all. Yeah. So by doing this and this and this, and I'm going to do this. Components and construct vector. Oh, but I didn't give it. Oh boy. Okay. Yes, I am clumsy at this point. Here. Oh, and now it broke again. Oh boy. Quong quong. Yeah, so I guess we're just gonna do the. I guess we're just gonna do the original plan, which was. Okay, so now we get it. So maybe we're just gonna do two videos. One is going to be using default parameters, and one is going to be error handling. And then the next one is going to be auto start on development. Whoa, okay. All right, so let's crank those out fast in a way. Okay. Let's do error handling first. So the way I'm going to do that is that I'm actually going to do the example again. Add new item. I'm just going to write it. Remove item component, and remove item is going to be, what is it going to be? It's going to be inside of data, so remove item. This is going to be remove item description removes an item from A3. Remove an item from a list. This is from a list, actually. Yes, it's from a list. And then category is going to be pcamp. And then this is going to be data. Register input parameters. pmanager is going to be the list. Add generic component, generic parameter, list L, list to remove from. And then it's going to be the type list, and then p manager add integer, and that's going to be index, and that's going to be lowercase I, index of element to remove, and then parameter access list, no, item, and and then the output is going to be the same list. Add generic parameter. The output was L out. The output was slash L clean list, and then that's going to be a list, and then here we have this. This is going to be a list of objects, and this is going to be L is a new list, and then if da dot get data list from 0 into L, then return. Okay. And then this is going to be if and in the input get data, that's 1, and that's reference I'm. This.com add runtime message. Okay. Okay, so this is what we would have, and so this is what we would have. It would be this, and it would be da dot set data list, and that's going to be just L as it is, and otherwise L dot remove at position I, and then just output that. So that's what we would have. And then okay. All right, so we're going to do error handling on this video. And then, okay. All right, let's do this. Hello, this is Jose Luis here at Parametric Camp, and welcome to a new video in this series, Advanced Development in Grasshopper, where I would like to teach you how to do error handling inside of native Grasshopper component. So how does that look like? If you remember from the previous video, in error handling, and a card should be popping up here, when we do this in C# scripting, what we do is we use the component property of C# script components to access the functionality of the component that we're living in, and we call add runtime message with all this other stuff. And the method is going to be super similar if we do it natively. So what I'm going to do is I'm going to replicate this remove item component that we did in previous examples, where what we do is we check if the index that we are given is out of bounds for the removal, and if it is, we display a message and we output a list that has had no changes on it. All right. So I have gone ahead and done a test implementation of this where I have created in the data components, I have created a remove item component class. I fill in all the properties, the names, whatever. I created an input, the first one, which is a list. You can see it here, and it's generic because I don't care what type of data is going to come in through the list. And then the second input is going to be an integer, which is going to be just a single one. Okay, and the output is also going to be a list with an access with a list as an access output, and then it's also going to be generic because it's going to be whichever the same type. It doesn't matter. And I have gone ahead and in the solver instance, I have created the placeholder variables to take in the input data, and I'm retrieving the input data using the data access argument. All right, so we have that. And this is the code, the original code that we have in the C# script component. So how are we going to do this? Well, it's going to be very easy. What I'm going to do is I'm going to adapt this code to the native Grasshopper way. And the way that works is that, first of all, instead of referring to the component of property, which if you remember was something that was part of the properties of a C# script component, and it was basically a way to tell the component how to be able to access its own properties. If we're doing native, we actually don't need this at all because we are already inside of the component. And because we don't have all the additional C# scripting overhead, we are working directly at the Grasshopper component level. All this functionality is already part of being a Grasshopper component. What that means is that if I replace this with the word this, meaning I want to add a runtime this to where I am, or simply altogether just remove it, this method is already part of the scope of the class that I am subclassing when I create new components. So I like to go for the this dot because I find it a bit cleaner, so that I see where things are coming from. You can see that it's clearly coming from the class. And then I just do the exact same thing, runtime message level of the warning type and with the message that I want to output. The only difference is that here, what I did in C# script is to set the output to the list without any changes and then stop execution of the component. Here, we don't set this way. If you remember, what we do is we say da.set data list, and then for the output 0 is going to be L, the list that I loaded with no modifications. But if I actually pass this test and the thing is correct, then what I would need to do is I would need to remove the element at that position, so that works fine, and also to output it in the same way. So I'm going to copy it and I'm going to output the list that has already had that element modified. So let me run this and see if it works. So let's give this a try. So I'm going to okay, I'm going to take components. I'm going to take this full data tree that I have here, and I'm going to go to data, remove item, and remove, for example, I'm going to remove the first item of the list. And you can see that because I chose list as an input, the component is working with each one, it's executing once for each list. So I'm with the first one, the second one, the third one, the fourth one, and now boom. At this point, number 4 is out of bounds, so I'm getting that error message. And then anywhere after that, I still get the error message and I'm getting the exact same output without any modifications. All right? So piece of cake. It's just simply finding where this method was inside of native Grasshopper components, which at this point is really in the scope of the class that we are subclassing. If we were to go to Grasshopper components, so maybe even here in the description, we might be able to find at runtime. Runtime, is that somewhere here? Okay, let me find it here. Yes, it is exactly here in the Grasshopper active object. So it's another class that we subclass as we subclass the component. All right. Beautiful. So that was it. Error handling in native Grasshopper components. Thank you very much. I hope this was useful. If it was, maybe pum 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 like sub. And if it wasn't, it's also fine. Let's move on to the next video in this series. Thank you. Bye bye. All right. What is the next thing? Default parameters. So if I drop a vector, okay, next video. Hello, this is Jose Luis here at Parametric Camp, and welcome to another video in this series, Advanced Development in Grasshopper. I've said this like a million times already, but I'm not getting tired of it. So what are we doing in this video? I'm going to teach you how to define default parameters for the inputs of components. What do I mean with this? So if you remember when we created the construct vector component, we just defined that it can get x, y, z values, right? But we used this kind of pattern that David Rotten recommends for taking inputs, which is if getting the data from the input failed, just stop executing the component. All right. What that leads to, well, actually not exactly that, other things, but one of the consequences of that is that if I do the following, for example, I just drop a simple construct vector with no inputs, then I get an error saying that X, Y, and Z fail to collect data, and I don't get any input, I don't get any vector output whatsoever. Whereas if I go to the actual native construct vector, this one here, if I drop it here, you can see that without any inputs, for some reason there's already X, Y, and Z predefined values here, and I already get a 0, 0 vector, which is actually often very useful because very often we create 0 vectors or vectors with just one input like X, Y, or Z, and it's kind of tedious to have to add zeros all the time. So what I would like to do is I would like to be able to define a way to add default parameters out of the box for certain parameters, for certain components. So for example, let's do that with our construct vector component. So first of all, let me try removing the pattern of if I didn't collect data, you have to fail. Okay, so I'm going to do this, and I'm going to add my semicolons here, and I'm going to try and see what's going to happen. What's going to happen is that, let me show you, I'm going to do that right now. What is going to happen is that I'm going to drop a construct vector here, and I still do get that same error. I still get the fail X, fail Y, fail Z for some reason, even though I am not canceling anything anytime here, and I actually do have default values for this variable, which is kind of weird. This is simply because Grasshopper is already managing stuff for us. Grasshopper, with the parameter manager and with all the additional stuff that goes into making Grasshopper work, Grasshopper is already taking care of looking at your inputs, figuring if there's any wire connected, and already gives you default errors for this. So then how could I add these default parameters? Well, if you remember, when I was adding number parameter or integer parameter or whatever, the method that I use actually has a bunch of different overloads. So let me actually so if I go to p manager.add number, for example, add number, and then I scroll through. So the basic overload was name, nickname, description, and access. If I scroll down through the overloads, you can see that the second overload comes with a default that I can add, and the third one comes with a list of default values in case the access is a list of elements, right? So what that means is that just by simply adding to the very end of the parameter the value that I want as the default here, okay, that is just enough. That is all I need to do here, okay? So let me actually now show you this in action. I'm going to execute this. I'm going to execute this. I'm going to open Grasshopper, and then I'm going to go here to drop a construct vector, and you can see that already I get a 0, a 0, and a 0 there, and V is already a 0, 0 component, a 0, 0 vector. All right. So that's just the simple way to add default values to the inputs of. But then you may ask, then Jose, like, why are you even bothering at giving these default values? Well, this is actually not default values. This is starter values just because of how C# as a language works. When we reference something, a value that is going to go into a primitive, that primitive has to be initialized. It's part of how C# works. The other thing is like, well, then why bother with this whole like, if you didn't get data, then return, blah, blah, blah. Well, it's kind of a nice thing to do because if you actually work with certain structures like trees or lists where there's no default and there's like, you can actually have empty inputs and that is value, that is valid, then making sure that you have those additional safeguards, especially if your components, if your algorithm is very hefty, it has a lot of computation, you save yourself all that computation, or even if the very fact that one of these lists or trees or input elements might be null, if that could break your code and crash Grasshopper, that is actually still a good practice to avoid that by returning in time and not allowing invalid values like null elements, etc., go through down in the rest of your algorithm. Okay, so it's still a good idea to have. But for primitives, we can actually get away with default values here and not even checking this if else, if I didn't get data, etc., etc. Okay. Beautiful. I think that was it for this video. And if you have noticed throughout these videos, the whole click and play, turning Rhino on, loading Grasshopper, etc., and loading this file that I use for debugging is kind of becoming a lot of overhead. So I think in the next video, what I'm going to teach you is a really quick trick to make sure that when we hit play here, Rhino opens, Grasshopper opens automatically as well, and we also load any file that we're using for debugging automatically. Okay, let me show you that on the next video. But in the meantime, like, sub, or not, whatever. Okay, thank you. See you on the next video. Bye bye. All right, so let's deliver the promise. So I'm going to. So first of all, where do I have that components file that I keep loading? Where do I have that file? I guess it's on my desktop. Components. I guess it's there. Okay, and um, oh, 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 oh. And where do I have? I did have an example of doing that, the post build events. Let me double check. Figure Grasshopper. Mm-hmm. Okay, so I'm going to open code here. And I'm going to open Grasshopper plugin, the project, and then you can see that. Okay, all right, so we're going to do that. Okay, let's do that. Hello, this is Jose Luis here at Parametric Camp, and welcome to another video in developing advanced stuff inside of Grasshopper. So in this video, what I would like to teach you is a tiny hack, a small hack, to streamline and make your development process a little faster. And that is because if you have noticed from all the previous videos, by using the Grasshopper development template inside of Visual Studio, you already have something that is very nice, which is the fact that when I click on Run this project, the Grasshopper plugin, then the Grasshopper plugin automatically opens Rhino for me. And it opens Rhino in a way that we will see in further videos, which is with all this code attached to it. So we will be able to pause at particular instance of the code and review the code, etc. We're going to see that further down the road. But something that is becoming very tedious for me is that when I open Rhino, when I click play, Rhino opens up, but that's it. Then I have to manually come here and click on Grasshopper to open Grasshopper, which on top of that opens on my other windows. So I have to like bring it over here, which is also, and then on top of that, I'm constantly using this one file. I'm constantly using this one file called components, where I have like all the stuff that I'm using for developing. So I have all these components that I'm kind of like halfway through writing, etc., which is a way that I work a lot myself. So I typically have like a Grasshopper file where I'm tinkering and messing things up, right? So, but I have to, that involves a lot of clicking. Every time I write code, I have to click and click and click. It's kind of not very nice. So one way we can optimize this process is by doing the following. So what I can do is I can configure my Visual Studio so that whenever I click run, run this project, to open Rhino and then to open Grasshopper and then to open a Grasshopper file, all of those at the same time. The way I'm going to do that is by hacking what's called the build events in the project. So what do I mean by that? So if I go to my actual file, you can see that I have to my actual project with a plugin, you can see that I have several files in the root of the project. And I'm actually, for this one, I'm going to open Visual Studio Code, not Visual Studio, because it's a little more lightweight, because I just want to read text files here. If you open the solution file inside of Visual Studio Code or any text editor, you can see a lot of information about the project, the Visual Studio version that you're using, the kind of the different modes that you have, etc., etc. So that's interesting. But most interesting is to open the CS project in a code editor. The CS project is basically an XML file that contains groups of properties that make this project work inside of Visual Studio. And for example, it's referencing the package, the Grasshopper package here, and I'm actually going to switch these two things. Yeah, so I'm going to switch these two things here. It has a pointer to where the resources are, the resource generator. It has like the PNG files that we have loaded, etc., etc. So that's interesting. But if you look closely here, there's this thing called a property group, which is a build property that happens when you are debugging. What this means is that this is the property that is telling the plugin project that every time I hit run, when I am in debug mode here, every time that I hit run, what Visual Studio should do is to start the program that is found under program files rhino.exe. So this is the actual line that connects hitting play with Rhino opening up automatically. What's interesting is that the call to the program accepts arguments. And what that means is that I can add more information to this call to Rhino in order to ask Rhino to do certain things as it starts. I just had an idea that I want to try. So let's say that I open a terminal. So if I open a terminal and I click this, this is going to not work. But if I do this, is this opening Rhino? Huh, interesting. Well, so maybe I go to here. So cd here and then rhino.x. Okay. And then that will open Rhino exactly. And I can do, what was it? No splash? All right, so let me Google that. Rhino no splash. No splash. And slash is saver. So Rhino no splash. Ah, but that's a typo. Okay, so no splash. Okay, so if I write then Rhino runs script. How would I do that from the command line? I guess. What if I do this? I can say run script, for example, equals line. And then it opens up. Run script line. Not working. Rhino run script command line. Rhino from the command line, run script command, second command. Oh, I see. So run script line, for example. Nope. Run script line. Oh, how was this? Anyone can help me here? A template, language, run a script, a startup. Running commands. Also maybe. Hmm. 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 I'm going to figure this out. I'm in the middle of the video. Okay, so this guy explains blah 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 from Rhino, safe mode, victim, no template. Yeah, but this is not working. Rhino and Python script form. No splash, run script. What about, oh, I haven't tried this one. Is this what no, but I have it the other way around in my, weird. Why is this not, okay, so run script. Okay, so let's say I type Grasshopper. Okay, so that's not working. Okay. Hyphen Grasshopper. Okay, also not working. Okay, can I just get the no splash? No splash. Run script. Grasshopper. Hey, Salvador. Hi, how you doing? Okay, so this is not working. Grasshopper. And it's not adding it. What is going on? Normally it's turn option general command list. But I'm not getting it, so no splash. I actually have here that it should be something like this. It should be underscore and hyphen. But it's not, probably because it's not a, it's in Rhino, tools, options, general. I'm not sure what you mean, Tim. But what I'm trying to do is something like this, you know, but just call a custom command here, basically. Maybe it's, oh, am I doing, is it because I'm using, oh, damn it. I've gone to this before. Yeah, it's command, I need a command prompt. Wait, so this is going to be the problem. So program files, Rhino 7 system. So I'm going to open a command prompt. No, not Ubuntu. I'm going to open a command prompt here. And I'm going to say Rhino, no splash, and then run script equals Grasshopper. Exactly, yes. I ran into this problem before. Yeah, the problem is that you can't use PowerShell. Okay, and then how about how about this? How about if I do run script, set grasshopper equals rhino. Yeah. Well, I don't need to do that really. Okay, so I think I can then now explain it. Rhino command line. Okay. So we were here. Okay. All right, so let's do this then. The idea that that running Rhino can take arguments is actually a consequence of the fact that Rhino can be initialized from the command line. And it can be initialized from the command line passing in additional data that we want to use to modify the behavior of how Rhino is going to start up. So let me show you an example. I'm going to go to where Rhino lives in my system, which is under program files, Rhino 7 and system. And in this folder, which is where I have the Rhino executable, I'm going to right click and I'm going to open here a command prompt terminal. It's important that you use command prompt and not PowerShell for the reasons that I will explain in a second. So if I open my command line here and now I type rhino.exe and I hit execute, then I can open Rhino from my command line, okay? But what's interesting is that I can do the same, but I can pass in arguments to define how I want that startup behavior. So for example, I can say / no splash, and what that will do is that it will open a Rhino where I do not have that splash screen with like my last files and the Rhino news or whatever, so it's a little faster to initialize. Or for example, something that I can do is I can say no splash, but also can you please run this script that I'm going to ask you to, and that's going to be equal to _grasshopper. So what I would like to do is I would like to make sure that you open Rhino and the first command that you execute is the grasshopper command. I use underscore to make sure that the command is not affected by different languages or whatever that is, okay? But you can see that adding a set of initial arguments to what do we want to make happen in Rhino as it starts is actually very easy. So similarly, this is what we can do here. This is the call to the program that we want to initialize, but we can add additional arguments here for to customize what's going to happen at the beginning. And the ones that I'm going to use in this case is going to be this whole thing that I'm going to copy paste from a previous project that I have here that is going to be all this stuff here. And let me show you a little bit of what's going on here. So what I'm going to do is that I'm going to execute a script as we open Rhino. And that script is going to be a script that is going to run a secondary script. That secondary script, instead of opening Grasshopper directly, what I would like to do is I would like to open Grasshopper, but I would like to open it in a way that it gives me an instance of Grasshopper as an object. So that once I have that instance of an object, I can issue further instructions that will take place inside of Grasshopper and not inside of Rhino at the root. So what that's going to be is that I set a variable called gh to be the Grasshopper instance that just got initialized. And then after that, on that instance, I'm going to call this method called openDocument, and then I'm going to pass in the route that I want to use for the document that I want to open. So that's going to be here under components. I'm going to right click here with the Shift key pressed, I'm going to copy as path. And then I am going to paste my route here. And I think I only need double quotes. I only need 2 double quotes because double quotes are escaped with double quotes themselves. So this is the full route of the file that I want to open. Okay. So I'm going to stop my command prompt, etc., etc. I'm going to save this as part of my Grasshopper project properties. And then let me try running my Grasshopper plugin again. So what I expect now is that it's going to open an instance of Rhino. It does have the splash screen. I haven't removed that. But you can see this whole thing that just got triggered. You can see that Grasshopper just opened up, and without me touching anything, the components file that I was using also opened up right away. Okay? So I find this technique very useful just because when I develop, I typically just do this all the time. I'm changing things, I want to hit play, and I want to land in this one file that I'm using as a bench, as a workbench, or as like some place where I'm testing code, I'm changing components, etc., etc. All right. So that's one way to speed up your development. I'm thinking about what I want to say now because I wanna bring in Timothy's suggestions of like reloading the assemblies without having to reload everything. I'm going to I would like to do that. So I want to think about how to frame that and when to start the video and how to start the video. So that would be okay. All right, let me frame this. Oh, actually, oh, and I forgot to say, if you want to learn more about running Rhino from the command line, there is a website there's a documentation on the Rhino developer docs that gives you further options and further command line options that you can input in when you fire your Rhino from the command line. Okay, so you can learn more about how to do that here in the documentation. Now, the second way to streamline your Grasshopper development is to actually bypass the whole idea of having to restart Rhino over and over again every time you make changes in your code. But let's think first, why are we doing that in the first place? The reason why we close Rhino, we make changes, we hit play, and we start Rhino again is because when we hit execute, what's happening in the background is two different things. First is that when we hit play, what's happening is that Visual Studio is taking all your code, is compiling it into the one file that becomes your actual plugin, and then it's saving that file somewhere. And then after that, it's opening Rhino, and it's making Rhino load that file with the technique that we saw in the previous video where we're talking about development, etc., etc. Maybe a card should be popping up here somewhere where we saw that. And then it's loading Rhino with that new library that you have just compiled. Those two steps, we can actually hack that process, because if, for example, let's say that we are here in Visual Studio, and I'm going to make these changes to the data tree, the tree information component, and I'm going to save them. If I save them, I am not compiling yet my new library. If you remember, when I compile libraries, they go into this binaries folder that is in my project and the debug net48, and this becomes the Grasshopper plugin. The last time I compiled this was at 12:31, and you can see that right now it's 12:37, so 6 minutes ago. So when I hit play, what happens is that, can you see how this file got updated, the time got updated? What happens is that automatically, and now the whole thing is starting with all the files, etc. What happens is that automatically Visual Studio compiles the file and then opens up Rhino. That compilation is actually called building. And building is a process that we can do on our own without triggering any more events after the fact. So for example, if I can say, let me just remove everything. Let me say that I'm going to change the code again, okay? And then I'm going to go here to build, and I'm going to click on build solution, just this. If I build a solution, what happens is that all these files get recreated, but nothing down the chain, the whole starting Rhino and attaching Visual Studio to it, none of that happens. The only thing is that I regenerate the files, okay? So what you can see is that the problem is that I would be able to use this as a way of just changing the files and hopefully having those effects show up in Grasshopper. But it doesn't really quite work that way. Let me show you. So for example, I have here the tree info component, the one that outputs all the data, all right? And my Rhino is open right now. So if I were to say, let me make these changes here, okay? Let me make these changes, I'm gonna save it, and I'm going to build the solution again. It would ask me, well, do you want to stop debugging? Yes, I'm going to stop debugging. I did build a solution, sorry, so let me go back. I'm going to, over again, I'm going to build a solution. And now I'm going to open an instance of Rhino that is not linked, that was not opened, that was not executed directly from Visual Studio. That is important because I want a Rhino to be independent from Visual Studio and don't have all the debug attachment, okay? So now I have components, I open components, the file, and then you can see that I have here my components, I have here my tree info, and this plugin, my plugin, has been loaded from my binaries file, okay? And I can actually, it has been loaded from my binaries file. So something that I could do theoretically right now would be, well, how about I just cancel all of this and I make the tree info component do absolutely nothing. I save this, and then I'm going to rebuild my solution. I'm going to rebuild my solution, and then the files get reloaded, etc., etc. But you can see that everything succeeded, and that my files now have the timestamp of 1240, which is the moment I just did this. If I go to Rhino and I look at the file, the component is still working as it was. And if I recompute, the component is still working as it was. And if I add a new component, which is tree info, and I try to plug it similar data, I still get all the data, even though I have deactivated that functionality from the plugin, and I have built that into the code. So this plugin here already does not incorporate that code. Why is this happening? This is happening because when Rhino starts, Rhino loads all the plugins that can find in the folders. It loads them in memory, and it only uses the versions that are stored in memory. So if the actual files change in the file system, like we build them again, or even I can delete them, and this is still going to work fine, right? I'm going to undo that. I can delete them and this will still work fine because Rhino is working with files that it loaded in memory when it started. What that means is that any changes that I make while Rhino is open are not going to show in Rhino. I would have to manually close Rhino. And then open it up again. And then as I open it up again, I'm going to open up Grasshopper again. I'm going to open the file the components file, and you can see that now that I have restarted everything, this component is doing nothing. All right, you see the problem? So the problem is I need to restart Rhino every time I make changes because I need Rhino to load those changes at the beginning of the startup. And I need to restart over again because every time I need changes, I need to basically refresh the memory and wipe the memory of Rhino. So how can we bypass that? Well, there is a small technique to do that, which I'm going to show you in a second. So I'm going to close the Grasshopper file that I had. And remember that that Grasshopper file, right now the algorithm doesn't do anything. So what I'm going to do is I'm going to activate again the functionality of tree info. Okay, I'm going to save this and I'm going to build the solution. The solution gets built, so now this file is updated. If I open the components file again, I still don't get that functionality because again, the Grasshopper plugin that is in memory right now, the one that is working in memory right now, is the one that was as Rhino started. So what I need to do now is I need to somehow refresh the memory of Rhino regarding all the Grasshopper plugins. So I need to tell Rhino somehow, forget about all the plugins you loaded, and can you please load them again? And the way to do that is by using in the command line in Rhino, using this command that is called Grasshopper and then reload assemblies, which as you can see doesn't have an autocomplete. But as I do that, as I press enter, you can see that all these components have been reloaded in memory: PTC, Booleans, triangulation, or pcamp Grasshopper plugin. This is the one that we were actually interested in. So Rhino went ahead, forgot everything that it knew about the plugins, and reloaded them again. If I go now to components and I load it again, you can see that the component now does have the updated functionality. All right, because I have forced Rhino to take another look at this file, the file that I just built, and update the new functionality. All right. Now, the downside of this is that this method is not very strongly recommended and actually is kind of discouraged by the author of Grasshopper, and that's why they removed it from the autocomplete. It's discouraged because messing up with memory, it's a tricky operation. It can be dangerous, and it can also mess up other things down the road. So it's actually not very encouraged to do that. So it's up to you. So if you want to use this method because you really are developing a lot of things really fast, just make sure that if you get errors here and then or things start working unpredictably, just restart Rhino again and do things over again. Also, this method that I'm showing you will not allow you to connect a running instance of your plugin to connect it to Rhino so that you can do breakpoints and dynamic debugging, as we will see in further videos down this road, okay? Because now Rhino is completely separate from Visual Studio. But still, it's a good technique to know. I believe that in order for this to work, you have to type Grasshopper developer settings, and you need to make sure that this option, assembly loading, is checked. I believe so, but I'm not entirely sure. So if what you're doing doesn't work, make sure that this is also working for you. All right? All right, beautiful. I hope this was useful. I hope you learned a couple techniques to make your development in Grasshopper with Rhino a little faster. And I hope that you now can develop a lot of things really fast and very awesomely. Okay. Okay, thank you very much. If you like this video, maybe hit the like button, subscribe to the channel, all those things. And see you on the next video in this series, which I don't really know what we're doing next, but I hope it's going to be awesome and interesting. See you. Bye-bye. Alrighty. And that's it for today. That was 4 videos. Okay, Timothy, thank you very much for the suggestion. I'm actually really happy about that. And I'm happy that we managed to introduce that into the main playlist. I really thought that that option was just gone. Okay. Oh, okay. Normally, I mentioned that together, would we next also be able to control the amount of other heavy plugins that are loaded in Grasshopper with the one specific component? Maybe with some ignore. With some ignore. What's going on? Hello. Okay, that was my niece calling. All right, so yes, whatever. Faster reload with a moving library follows around. Yes, yeah, that would be cool, I guess. Anyway, I'm going to go. It's a little late. That went on for longer than I thought. And my niece, I told my niece that I would call her right now. So. So it was a pleasure to be here with all of you. And remember, next week is the 100th parametric camp live stream, and we're going to celebrate by having a tiny surprise that is going to involve some guests. Okay, so I really hope that you will join us for that. Thank you very much, and see you next week. Bye bye.